So for example, from this point forward, when I talk about a honeybee behavior, I'll name the behavior, in this case, cell preparation. I'll tell you the range of ages bees are when they perform that task, and I'll tell you what the average age of the worker bee is who performs that task. So they prepare cells when they are 2 to 16 days old, and the average worker bee that's preparing cells is somewhere in the neighborhood of 8 days old. All right, so I want you to keep that in mind as we progress through all the slides. So in this particular instance, we're specifically talking about cell preparation. I think you'll agree with me that that is a pretty fantastic image that Dr. Bentley provided for this picture, or for this slide. All right, so what is cell preparation? Well, there's really two subcategories. That's polishing the cell and cleaning the cell. And I know they sound like they're the same, but they're not. Both of those are used to get that cell ready for use. But polishing is the first task that occurs at this age. Cell cleaning happens later in life, and we'll get to it in subsequent slide. So hold on to that thought. So when I'm talking about cell preparation at the youngest of age, I'm specifically talking about polishing cells as a subsection of cell preparation. All right, so in this behavior, the worker bees go to the very back of the cell and go from the back to the front, removing anything left over from previous cell occupants. That might be pupal cocoons, excretia, so their waste. They might be patching the walls of the cell with wax, etc. So they're essentially taking the debris out of used cells in an attempt to get those cells ready for future use. Remember, pupal cocoons would be that little bit of silk that the larvae spin when they're ready to pupate. Most people don't know this, but honeybee larvae actually produce silk, not in the quantities that, say, a butterfly or a moth would produce, but they still produce it. And that is one of the reasons that the cells darken over time. So when a bee emerges from a cell, the bees that are engaged in polishing subtask of cell preparation will go in and start removing those pupal cocoons, and that excretia includes waste. It also includes the old exoskeletons that the larvae and the pupae shed when ultimately maturing and becoming an adult bee. So those bees that are polishing cells have a very important task. All right, the next task that they perform is cell capping. The reason this is usually a second task is worker bees are not born with the ability to start producing wax instantly. Their wax glands are not fully developed. So it takes a couple of days for their wax glands to develop, but once they do, the young worker bees can start to secrete that wax in very small amounts. And what they'll do is they'll use that wax to cap over the cells of the developing larvae, those larvae that are finished feeding, that are about to become prepupae. These young workers will begin to secrete tiny amounts of wax and use leftover wax to start capping over those cells. Interestingly enough, it can take somewhere in the neighborhood of 20 minutes to 6 hours to cap a single cell, depending on the number of workers working on that cell, as well as the amount of wax that they are able to produce at the time that they are capping over that cell. The next task that worker bees will find themselves performing is feeding larvae, and they tend to feed larvae when they're about 3 to 15 days old and an average of 10 days. The workers that perform this task are called nurse bees. And the reason that workers can't be born and instantly begin to feed larvae is that they have to develop their glands necessary to produce brood food. Worker bees have two sets of glands in their heads that they use to secrete the components of brood food. That includes the hypopharyngeal glands and the mandibular glands. So essentially, when a worker bee is born, she begins eating pollen in order to develop her hypopharyngeal and mandibular glands appropriately. And once she has those adequately developed, they can begin to produce brood food. That's why they don't come right out of the cell and start doing this instantly. They've got to develop those food-producing glands. Once they do have those glands developed, they're able to secrete those food components, and then they're able to feed the larvae. So the adult nurse bees are the ones who decide when to feed larvae and what proportional mix of brood food to feed based on the age of those larvae. For example, as a worker or a queen larvae or a drone larvae ages, the components of their diets change. So nurse bees, when they visit those open cells and determine how old that larva is and the nutritional requirements that that larva has, can change the proportion of secretions from hypopharyngeal and mandibular glands to produce the food that is relevant or important for the age of larva that they are feeding. What's interesting in this regard is that larvae, as they develop, may have their cells visited 5,000 plus times, with them being fed somewhere in the neighborhood of 1 to 2,000 of those times. So those larvae, worker larvae especially, are provisioned incrementally. They're given food in small amounts over time. So you can imagine then that those workers who are responsible for feeding larvae have a daunting task in front of them. They spend quite a lot of time when their heads and cells spitting up food for the developing offspring. The next task that worker bees do or perform while they are developing is they tend to the queens. They usually do this when they're about 3 to 14 days old, and usually are on average of about 11 days old when they do this. This task is usually performed around the same times they're feeding brood, and that's because a lot of the same behavioral characteristics that these workers need to have, they use when feeding brood. All right, so worker bees will form a circle around the queen. We call this circle a retinue. They're attracted to the queen by her pheromones, and they will lick the queen, they'll groom the queen, they'll feed the queen, and they'll examine her with their antenna and forelegs. So all of this allows them to pick up the pheromones of the queen, distribute those pheromones to nearby workers, who distribute it to nearby workers, who distribute it to nearby workers, and essentially pass the pheromones of the queen around the nest, which tells all the workers in the nest that we have a queen present, life is good. So these bees, even though they seemingly have an unimportant task, actually have an incredibly important task, because part of what they do is share with the hive that we have a queen, life is good. And furthermore, they take care of that queen, who is that important bee needed to produce all the offspring in the nest. Next, you get workers that are involved in honey production. These workers are 10 to 20 days old. They are on average around 13 days old. Now, one of the beliefs I had when I was a new beekeeper is that bees that are nectar foragers go out and collect nectar from flowers and fly it back to their hives. And when they get to the hive, they'll go to find an empty cell and spit up that nectar into those cells. Well, that is not the case. There is actually a cohort of worker bees, the honey producers, whose job it is to meet the incoming nectar foragers at the nest entrance. So these bees will actually be waiting just inside the nest entrance for those nectar foragers to arrive. And once those nectar foragers arrive, these bees will take that nectar from those nectar foragers, so the nectar foragers can turn around and go right back out. And these bees then will take that nectar and take it to the cells where it needs to be deposited. But before these workers deposit that nectar in cells, they will start the conversion of that nectar from nectar to honey by starting the evaporation process. And they do this by blowing nectar bubbles. So they basically spit out the nectar and suck it back in. They spit it out and they suck it back in. They spit it out and they suck it back in. They spit it out and suck it back in. And they do this for about 20 minutes, and then they put it into the cells. And basically during that time, they've added some enzymes, they've started the dehydration process, and they're basically pushing that nectar in the direction of becoming honey. When bees graduate from that task, they usually move on to cleaning cell debris. Bees that are cleaning cell debris usually are in the neighborhood of 11 to 15 days old, and that mean age is around 14 days old. So these workers are the ones who remove debris from the hive. That will include spoiled pollen, it'll include wax, it'll include dead brood and dead bees. These are the undertakers, as it were. These are the same workers that exhibit hygienic behavior. These are the ones that are able to detect diseased brood under capped cells, uncap those cells, and remove that diseased brood from the nest. So clearly this cohort of bees, the ones that are performing this task, have a very important function in the overall health and homeostasis in the nest. Next, you get the pollen handling bees. And these bees are not the ones that are going to collect the pollen. It's kind of reminiscent of the nectar handlers. These aren't the ones going to collect the nectar. They just meet the bees at the nest entrance to collect nectar from them and run them to the combs. Here, the pollen handlers are not the ones that go collect pollen. They're the ones that process it. However, for the nectar handlers met the nectar foragers at the nest entrance. In the case of pollen foragers, the pollen foragers are the ones who go and deposit the pollen in cells. Here you can see a pollen forager with the pollen on her hind legs. She's checking out this cell to determine that it's a cell that she wants to deposit pollen into. And once she determines that's what she wants to do, she'll back her hind legs up to that cell and knock those pollen balls off of her hind legs into those cells. After she has knocked that pollen off of her hind legs into those cells, that is when the pollen handlers take over. These bees will then go and take those little pellets that the pollen foragers collected, and they'll start to pack those pellets into the cells until you get these smooth pollen packed cells, just like what you see in the image in the bottom left. All of these cells have been processed by the pollen handlers. They're the ones who start the conversion of that pollen from pollen to bee bread. Following this, worker bees might engage in a behavior called comb building. They typically are 12 to 23 days old when they do this and are on average around 16 days old. At about 12 days after emerging, the workers' wax-producing glands have fully developed. So the reason they can't really engage in comb building behavior earlier is that they're just simply unable to produce copious amounts of wax. Remember, I mentioned earlier they can produce small amounts of wax, which allows them to deposit, to cap over brood cells, etc. But now at this age, they're able to produce copious amounts of wax and then use that wax to build comb. We all know that these wax glands are located on the underside of the abdomen. They'll secrete these sheets of wax, just like you see in this image, and they'll remove those little scales of wax, chew them with their mandibles, and fashion it into the six-sided combs with which we are all familiar. After that, when they're somewhere in the neighborhood of 11 to 25 days old, for an average of about 13 days, the workers will move to that second phase of cell cleaning. Remember, the first thing they do is clean cells, but from the polishing perspective. Now they are cleaning it from another perspective. So these workers will use their mandibles to restore and smooth cells, remove the cell cappings, and prepare the cell for future use. It can take them around 30 minutes to clean a cell when they're this age, and it usually is somewhere in the neighborhood of 5 to 30 workers helping prepare that cell. So you get the young cleaning behavior, which is where they're polishing the cell. And now you get the older cleaning behavior where they're smoothing the cell and making its final preparations necessary for that cell to be occupied either by nectar or pollen or an egg. At this point, somewhere in the neighborhood of 2 to 25 days old for an average of about 19 days, the workers transition from behaviors that occur inside the nest to behaviors that occur outside of the nest. And the first behavior that you typically find them engaged in outside of the nest is ventilating the nest. There's a very characteristic ventilating the nest posture where the bees will stick their abdomens up in the air like you see here. They're raised really high. The back end of their bodies is raised really high up in the air. They'll push their back forelegs up really high, and they'll be ventilating that nest by fanning their wings. You can see this be an incredibly characteristic pose. This bee here is doing the same thing. It's almost like they're in the beginning stages of a push-up where they've lowered the front half of their body down, but then they just get stuck there while they fan their wings. So these bees can either point towards the nest or away from the nest and controls, therefore, the direction that the air passes either into or out of the nest. So this ventilating allows them to cool the nest, and it also allows them to evaporate a lot of the moisture from the honey or from the nectar that they are trying to ripen. Hundreds of worker bees can perform this task at any given time. Next, you get my favorite image that Mike Bentley took. He took a picture of guard bees, and after ventilating, bees typically move into the guard bee behaviors. They're usually somewhere in the neighborhood of 15 to 28 days old when they do this, for a mean of about 19 days. And just like the ventilators had a very characteristic pose, the guard bees have an even more characteristic, dare I say, menacing pose. And in this pose, their hind forelegs are low to the ground, and their front two legs are in the air, and their mandibles are open. So you see this bee very characteristically doing it. This bee is doing it as well. This other bee that's a little bit out of focus is doing it. And so basically these guard bees sit at the nest entrance, and when another bee lands and walks by them, they will kind of reach out towards that bee and antenate with it. They'll rub their antenna on that bee and determine if that bee is friend or foe. If it's foe, it gets attacked. If it's friend, it's allowed into the nest. Now, when bees are somewhere in the neighborhood of 17 to 27 days old, somewhere around an average of about 23 days, the workers will begin to transition to foraging-based tasks. And this will begin with short orientation flights. Remember, these workers haven't left their nest. They don't know where their nest is in relation to the rest of the world. So they'll start taking very short circular flights around the entrance of the nest and then land back on the entrance. And then they'll fly a little bit further away and then land back on the entrance of the nest. And then they'll fly further away still and then land back on the entrance of the nest. And so they go back and forth, gradually expanding their flight area until they get comfortable knowing where their nest is relative to other landmarks in the environment, trees, ponds, etc., or bodies of water. So these orientation flights tend to occur on warm, windless, sunny afternoons, and they can be incredibly intense. In fact, a lot of people who walk by their hives who see an orientation flight get instantly overwhelmed because they think their colonies are on the verge of swarming, when it's usually just an orientation flight where hundreds or sometimes even thousands of bees have finally graduated to the task that will take them outside of the nest, and they're just trying to figure out how to fly and where home is. The final kind of rigid or semi-rigid task that worker bees will find themselves doing is foraging. They're usually in the neighborhood of 18 to 28 days old, or an average of 24 days when they perform this task. This is the task that will kill the bee. If they've survived this far, this is the task that they will do dying, or die doing. All right, so on average, a worker honeybee will forage for about 4 to 5 days and cover somewhere in the neighborhood of 500 miles. And so that seems to be the flight capacity of a worker. After they've hit this, their wings are tattered, their bodies are worn, and they just no longer have the energy to continue performing this task. So we refer to these workers as foragers, and when they leave the nest, they are collecting one of 4 things: nectar to convert to honey, pollen to convert to bee bread, water that they sprinkle around the nest and evaporate off for thermoregulation purposes, and plant rosins, which we affectionately know as propolis. So they're going out to collect nectar, pollen, water, or plant rosins. And once they've collected one of these things, here you've got a worker bee collecting nectar. You can see her tongue extended into the bottom of the flower. Here, this in the image in the upper right, you've got a bee who's collected pollen. You can see the pollen on her hind leg. Of course, the bee in the image on the bottom is collecting water. You know she's on water because you can see the reflection in the water from her standing in a very shallow pool of water. And once they've collected these things, they'll go back and communicate information about these forage resources to their sisters in recruitment dances. And with these dances, they're able to communicate location, distance, and the quality of the source relative to the sun and the nest site. Now, what I've given you so far are some rare, fairly predictable tasks that worker bees perform more or less as they age. There are some assorted tasks that worker bees can find themselves engaged in, and a lot of these are independent of age. Some of them are age dependent, and you'll see an example in a moment, but some of them are independent of age. In other words, a wide range of ages of worker bees might be engaged in these behaviors. So some of these other behavioral tasks include what we call bearding. Every summer when it gets hot in Florida, I'll get dozens of emails and phone calls from brand new beekeepers who are so concerned about this huge cluster of bees that's hanging on the face of their hive. What's going to happen? Are they swarming? What's happening? And that's just bearding behavior. You can see in this image a really small beard. It's just tiny, more like a stubble, as it were. But the reason we call it bearding behavior is it looks like a beard on the face of that hive. So bearding is probably, we think it's a way to avoid overheating the nest during summer, during warm months. So the bees that are otherwise have no task to perform will leave the nest so that the inside of that nest does not overheat while the bee colony is trying to rear brood. Thermoregulation, we know we've already talked about the fact there are water foragers. There are also ventilator bees. So the bees that perform the cooling of the nest are a fairly predictable age. However, in winter, when it gets incredibly cold in some places and bees start to warm the hive, that kind of temporal polyethism breaks down a bit. So worker bees can also participate in the warming of the nest during fall and winter. And that's a very complex behavior where they will unhinge their wings from their flight muscles and shiver those muscles that generates heat. And you get lots of bees doing this simultaneously, and it can raise the nest temperature to a temperature necessary to keep the brood warm or keep the bees sufficiently warm so that they don't die themselves. They will go into empty cells. They will go between frames just to make a very contiguous and consistent cluster. The behavior is so complex that the bees on the outside the cluster oftentimes get too cold to move. So the bees inside the cluster will pull the bees on the outside the cluster into the cluster to warm up and then take their place. So it's a very complex behavior, is warming the colony. It's funny because they cool and warm the colony two completely different ways, right? For cooling the colony, they collect water and they fan their wings. For heating the colony, they cluster tightly and shiver their flight muscles. But nevertheless, these series of behaviors allows them to thermoregulate the nest. Some workers can lay eggs. We of course call these laying workers. There are times when a colony will go hopelessly queenless and the bees fail to make a queen for whatever reason. And when that happens, some of the workers' ovaries may develop. And when that occurs, those workers can begin to lay eggs, but workers don't have a spermatheca. They cannot mate, so they cannot fertilize eggs. So when workers become laying workers, they can only produce unfertilized eggs or drones. So a colony that's headed by laying workers is doomed because drones are otherwise useless in this regard and can't perform the tasks of the hive, so the colony is doomed. People believe that laying workers is a phenomenon in the first place because the colony is doomed, and so this is their last ditch attempt to get their genetics into the environment. Some worker bees engage in what we call patrolling behavior, where they're simply behaviorless at the moment. They are taskless, I guess is a better term. They're taskless. They don't have a specific task that they're performing, and instead they're patrolling, trying to understand the feedback loops to determine what is needed at that moment. What is it that they need to do? What task is underperformed that needs to be addressed? All workers, after about a day or two old, are capable of participating in a defensive response. Generally speaking, it's the guard bees at the nest entrance that will initiate this defensive response, but all worker bees are capable of engaging in it. If you've ever gotten a colony really hot before and elicited a significant defensive response, workers across the age spectrum are participating in attacking you and stinging you. I just thought I would throw this image into this presentation just to give you a full scale appreciation for how beautiful the stinger is of a worker in the first place. In fact, probably after all of you hear me talk about this slide, you're going to want to run out and have yourself stung just so you can see this stinger in all of its glory. But in this image on the left, are the venom glands. These glands are the ones that produce the venom. They release their venom into B, which is the venom sac. It holds the venom in storage until use. C is a muscular bulb that when you get stung, the muscles contract and pump the venom from B through the muscles and through the sting shaft D into your body. So A is where the venom's produced, B is where the venom's stored, C is what pumps the venom, and D is what delivers it straight to the point of contact. In the image in the upper right, A, B, and C are the parts of the sting shaft. D is the part of the shaft that comes really high that responds to the contraction of the muscle. When this side of the muscle contracts, it forces this part of the shaft further into your body. Then when this side of the muscle contracts, it forces its part of the shaft further into your body. So as you are stung and that muscular bulb beats, basically it's working this sting shaft further and further and further into your body. One of the funny things about worker bees that most people do not know is that they actually spend the vast majority of their time not working at all. They actually spend the vast majority of their time resting. Everybody says as busy as a bee. That's one of those sayings that we all use. We want our employees to be as busy as a bee. We want our kids at school to be as busy as a bee, but you actually don't want them to be as busy as a bee because the vast majority of the time the workers are resting. In fact, if we called them by what they do most, we'd call them resters and not workers. And the reason people don't see that is when you pull out a frame from your hive, your eyes are instantly drawn to the moving bees, not the ones standing still. The next time you work your colonies, I want you to look at a frame and see how many workers are actually resting. Another assorted task is robbing. During certain times of the year, especially during nectar dearth, some bees will exhibit robbing behavior where they stop foraging and begin to try to steal resources from other colonies. In the image in the bottom left, these workers are trying to steal it from a feeder jar, but they can also work their way into the entrance of a hive or through the cracks and crevices of another colony's hive to try to steal resources from typically weakened hives. Worker bees also engage in grooming behavior, which is where they lick and comb themselves, as well, whereas in addition to the siblings, they'll clean one another. They also engage in trophallaxis, which is a very fancy way to say that they feed one another. Basically, a bee that has nectar in her crop will be solicited by other bees who are hungry, and this bee will begin regurgitating nectar. And in this case, in the image, you can see the two bees on the left have stuck out their tongues to the mouth parts of the bee on the right because the bee on the right is donating nectar and the bees on the left are receiving that nectar. They're feeding one another, and we call this behavior trophallaxis. I want to wind down with two more behaviors of worker bees, and they're complex behaviors that kind of transcend, at least this one's a complex behavior that transcends the other task. You know, we've talked about this temporal polyethism, the series of tasks that worker bees progress through as they age, but there's this complicated worker task that's wrapped up in this thing that we call swarming. Now, the swarm is basically reproduction at the colony level. Bees don't reproduce, honeybees don't reproduce in more bees. They reproduce in more colonies, and we call this reproduction swarming. All right? In the swarming process, the older colony will usually start to rear several new queens. Then about 30 to 70% of the workers and the old queen will leave the nest and form a cluster like what you see here. Scout bees leave this cluster and canvass the countryside for potential nest sites. They'll go into these nest sites, measure characteristics about those nest sites, and come back to the surface of this cluster and dance on the surface of this cluster to communicate the quality of the nest sites they found to the workers that are in that cluster. Once the workers have, for lack of a better term, voted on the nest site that they want to move into as their new home, they will collectively release from this holding pattern, fly to the new nest site, and then create a new nest. Now, I have incredibly oversimplified the swarming process, but you'll see it is a whole new series of behaviors that worker bees engage in that we never attribute to them when we're talking about standard worker bee tasks. I mean, they have to know when to initiate the swarm. Heck, they have to know how to prepare to swarm. Once they're swarming, they have to figure out how to collectively coalesce in a cluster. Then they have to know how to find new nest sites, dance for those nest sites, choose the new nest site, and move into the new nest site. Worker bees' behavioral repertoire is far more complex than we typically give them credit for. The final series of tasks that I'll talk about are a series of tasks that is a task that exclusively the foraging or the scout bees do. And the scout bees for swarming instances and foraging bees for those that are trying to collect food, and that's dancing. The foraging bees can communicate food resources through dances. I'm just going to briefly go over this. I don't want to spend much time here, but essentially when bees have found, worker bees have found a quality food resource less than or fewer than 15 meters away from the hive, they will communicate that food resource, information about that food resource, in a round dance, a circular dance. When the food resources are over 100 meters or so from the nest, they'll use this figure-8 dance, or their waggle dance, as it's affectionately called. And in the waggle dance, there's a straight run and a right circuit, and a straight run and a left circuit, and a straight run and a right circuit, and then a straight run and a left circuit. The direction of that straight run relative to up on the comb is the direction of the food resource relative to the sun. So for example, the straight run on this dance is straight up. That tells the worker bees watching this dance that the food resource is in the direction of the sun when you leave the hive. In this case, on the right, the straight run is 45 degrees to the right of up. So the worker bee is communicating that the food resource is 45 degrees to the right of the sun when you leave the hive. If the straight run were straight down, then the food resource would be exactly opposite of the sun, and so on. So worker honeybees are capable of performing incredibly complex dances, and if they're on the receiving end of this dance, they're able to interpret what the dance means and then use that interpreted information to go find the forage that their sister's trying to communicate. There's a lot more detail to the dancing. I just wanted to give it a brief overview, but it's another behavior that worker bees find themselves engaged in doing. All right, so I've only got about 3 minutes left on this talk. So I want us all to take a collective deep breath and look at this bee that I've just described for you. I want to remind you that this bee came from the same egg that a queen bee came from. This bee could have been a queen, yet she's not. And because she's not, she has the most complicated series of tasks that she can perform, probably of any other bee species known. This bee can feed other bees and build a nest. This bee can defend a nest and steal resources from other colonies. This bee can dance. This bee can find a new nest site. This bee can clean itself and others. This bee can make honey. This bee can process pollen. The worker honeybee is an amazing creature. Everything that she's done is pre-packaged in that little old body capable of so much. As I wind down, I'd like to thank you for listening to me. Hopefully this whole distance part was okay, and that the quality of my sound and the imagery was good for you. If you've enjoyed what I've been able to share with you, I invite you to follow my laboratory on Twitter, Instagram, and Facebook. You can find us there at UF Honeybee Lab, and you can follow my lab online at www.ufhoneybee.com. We have an amazing podcast that you can find there for free. We have a lot of online training material that you can find there, a lot of resources that you can find at our website. Hopefully you'll be able to visit our website and take advantage of some of what we have there. And finally, I have my email address here that you can use to contact me. So I'd like to thank you all for attention, and I hope you enjoyed listening to me talk about the tasks of worker honeybees.